this is the project we were doing. Okay, and so we have designed the foundation, like the foundation layout. We have like first we will prepare the foundation layout, then we will design the foundation in safe. Okay, so you can see this is the we have designed it. We have checked for the bearing pressure. We have checked for the punching also. Okay, so let me give you the brief recap of my previous class. Okay, so from here you can show see the undeformed shape. Okay, so this is our foundation. I have so let's click the origin here and soil support. Invisible point is there. Okay, and okay. So now you can see everything. Okay, and let's see the results like the soil pressure. Okay, the ground the SPC we will see. So what are the results we are getting in like what are the maximum soil pressure we are getting in the foundation right now. So here you can see at the each foundation it's 190. So our permissible limit is around, you can see here it's 235. So we are getting 190, so it's perfect. It's 190 here, 166 here, 188 is here, 188, 181, 179, 190, 191, 191, 189, 180, 177, 161, 181, 182, 182, 181, and 161. And here it's 69 or 69, 68. Okay, so yeah, so it's a very small foundation, so that's why it's 69. Okay, so keep it like this. Okay, don't need to decrease the size. Okay, at least we will provide this minimum size for these foundation, because there is a very less load at this location. Okay, so I think all the foundation, the soil pressure is under the permissible limit. So now we will check for the punching. You can see. So punching is around point 0.8, 0.83, 0.82, 0.72, 0.83, 0.76, 0.75, 0.68. Okay. So I think these are the perfect results we are getting in the foundation right now. So suppose you are getting point 0.9, 0.95. So what you can do, you can increase the depth by 50 mm. Okay, you can, or you can, if you are getting like uh, suppose you are getting almost point 0.5. So what you can do, you can decrease the depth by 50 mm. Okay, so your results will should be around 70% to 90%. Okay, it's in between that. So here you can see it's 0.68. Okay, so it's, I think like it's equal to 70%. Okay, it's very close. Okay, so you can leave it 0.68. So that's how you will get the perfect results. Okay, let me open my presentation. So you can increase the like size. You can decrease the size if you are if your result is not between 70 to 80% or 90%. You can do whatever changes you want. Okay, and so I'm giving you the recap about the foundation design, what we have done it. Okay, so we have exported load cases and the load combination from ETAB model. Then we have defined the material property, that is concrete grade and steel grade. And then we will define the slab properties, and then we will assign the slab properties, and we will draw columns and wall. Okay, so in our model right now, it's a G+3. There is no walls, that's why we have not modeled any wall here. And we will assign the subgrade modulus. Okay, so as per the soil report, as per the geotechnical report, you have to go through the geotechnical report, and you need to check everything in the geotechnical report, and you have to calculate the SPC, soil bearing safe bearing pressure, and then you have to calculate the net bearing pressure, that is Safe bearing pressure is equals to, I think net bearing pressure is equals to safe bearing pressure minus overburden pressure, and you have to take the net bearing pressure into the calculation. Okay, and we have to update the design code every time. Please make sure you have update the design code. Right here it should be IS 456 2000, and factor of safety for the steel is 1.15. Factor of safety for the concrete, it should be 1.5 here. Okay, and so for the reinforcement check, what we will do, we will draw the design strips. Okay, so let's draw the design strips. Okay, so to draw the design strip, you have to unlock the model first. Okay, and you have to check the what is the size. Okay, so what is the size? Let's check for this these two foundation. Okay, so to check the size, you have to go to the draw dimension line, and let's check the, it's 2.2, and it's also 2.2. So from here you can see draw design strip. You have to take this tool from here, and here you can see the type of the object is a strip. Okay, and strip layer is A. So A layer is in the X direction layer. Okay, it will give you the reinforcement in the X direction, and here you can see the start width and the end width. It should be, suppose the total length of the foundation is 2.2, so it should be half of that, half of 2.2. So half of 2.2 is 1.1, and you have to copy this and paste at the remaining blocks. Okay, so you have to take the middle point from here, and you can see, so we have successfully draw the strip. Okay, so here you can see the width is not visible for the strip. Okay, so to visible the strip, to open the visibility of the strip width, you have to go to the set display option. Here you have please click the checkbox, strip width. Okay, where is the strip? Yeah, so here you can see design strip object. So you have to tick the checkbox. Okay, it should be tick yes at the checkbox and click OK. Now you can see the width. Okay, it's a proper width is here. So suppose I have taken the wrong width for the strip. Okay, so here you can see the rebar material is also different. Okay, it should be fe 500. So you have to always make sure you are taking rebar material should be fe 500 here. Okay, you can see it's a column strip, and click OK. Suppose let's go to the geometry. Here are all are the width. Suppose I have taken wrong width. Okay, let's take it 0 0.5. Okay, copy this, paste here, paste here, paste here, and OK, and OK. So you can see the width is different. So please make sure you are taking the right width for the reinforcement. So let's take it again. It should be 1.1, and it's perfect. Okay, so go to the draw design strip again. It should be A here. It should be column strip, and draw the strip again. Okay, and similar for the y direction, you have to take B here and click to okay. So you have to like check the what check the dimension. Okay, please check the dimension. You can see it's 2 meter here. Okay, so you have to take it 1. Okay, and draw it in the vertical direction. Okay, so we have successfully draw the design strip along the length, or along the length and along the width both. Okay, so now what we will do, we will do it for rest of the foundation. So go to the draw dimension. So I'm doing it very quickly. Okay, so it's 1.7 and it's 1.5. Okay, and let's go to the draw dimension. And it's 1.8. It's 1.6. Okay, so let's go to here and dimension line and click OK. Mm. So okay, what I have done, I have draw all the dimensions. Okay, so like for your convenience, what you can do, you can draw all the dimensions. Okay, so it will be better for you to see uh, which of the dimensions are same, or you can draw these strips. Okay, and okay, so let's do it like this. Mm, everything's perfect. So let's take a design strip. Let's take a design strip, okay? And you can see here it's 1.7. Okay, so it should be 1.7 by 2. So you can calculate 1.7 by 2 here also, and you can copy it. You can paste uh, at every, you can see at every width you have to take 0.85. Okay, so let's draw this. Okay, and let's see 1.7 more 1.7. I think okay, there is this one is 1.7. Okay, it's perfect. And let's see in the vertical there is 1.7 or not. Okay, there is only 1.7 is one. There is only two foundation whose width or length is 1.7. Okay, so let's take it 1.6, 1.6 divided by 2. Let's copy this, paste, and paste. Okay, and I think it's 1.6 draw like this. Okay, and it's also 1.6 draw here, and it's 1.6 draw here, and it's 1.6 draw here also. Okay, I think there is okay no. So I think there is a B also, right? It should be it's 1.6. No, okay, it is not okay. So it's this dimension is wrong. Okay, let's draw again. Draw dimension line. Okay, it's 1.5. So so it's 1.6. You can see. Okay. Like whenever you are doing, uh, you are doing draw design strip for vertical direction, you have to take it strip layer B. Okay, please make sure it's B. Don't don't draw a strip layer in the vertical direction. Always take B in the vertical direction and A in the horizontal direction. Okay, it's that simple actually. So you can take it like this, and you can take it like this. You can take it like this. No, this is not okay. So let's do it for 1.6, 1.5. Okay, so for 1.5, let's take it for A and 1.5 by 2. Okay, and I think it should be 1.5 like this, and it should be like this. Okay, okay, 1 minute. Okay, it should be one in either X direction. Okay, okay, 1.5. This is 1.5. This is also 1.5. And let's take B again, and it should be 1.5, and it should be 1.5, and it should be 1.5 here. It should be 1.5 here again. Okay, I think it's perfect. Let's do it for 1.8. I think it's okay. So for vertical direction also we will take it. And now let's do it for 1.9. Here you can see 1.9 is there. Okay, so let's take it 1.9 by 2, and let's copy this. Okay, and for a direction, x direction, a, it's like this. Okay, and yeah, I think for b also we will take it. It should be like this, and it should be like this. Okay, and now for 2.1, we will take 2.1 by 2. For vertical direction also we will take it. Okay, and for 2.5 now we will take. Okay, so it's 1 by 2. Okay, it's point 0.5. Copy, paste, paste, paste. Okay, for a you have to take it like this, and for b it should be. So it's perfect. Okay, we have in very less time we have draw all the strips here, horizontal or vertical. That is horizontal, that is A, and vertical, that is B. What you can do, you can untick the checkbox. Okay, and you can see if you can't now, you can't see the dimension also. Okay, so we have draw the design strip layer one, layer A or layer B. Okay, so here you can see we have assigned the 2D degree of freedom. Please always check you have assigned this one. Otherwise, you will get the wrong results. Okay, so I think run advanced modeling option. It's please make sure active degree of freedom you have assigned it. Okay, and you can see here what active degree of freedom it's a 2D plate. What 2D plate do, that is giving us the only deflection in z direction. Okay, and rotation in x and y direction that we want only. Okay, because in the foundation it's surrounded by the uh, earth. Okay, and so I think it's restrained. X and Y deflection in the X and Y direction is restrained by the soil is available at the ground. Okay, and we need only deflection in that direction. That's why we are doing it. So there is no beam in the. You can see there is no beam. Okay, so we don't have to delete any beam. So whenever we are taking the wall in the model, that is in E tabs. Okay, so whenever we are exporting the model from E tab to safe, of at the wall location there will be a beam. You have to delete the beam every time. Okay, so here you can see the deflection check. So I think we have already done the stability checks. Okay, we have already done the SPC check. We have already done the punching check. Okay, so uplift in the footing it should be 0. Okay, so let's check this. Okay, let's we are checking about this right now. Okay, so if you go to the deflection, let's run it. Okay, so if you go to the deflection and let's select the load combination, dead load plus live load, and apply, you can see maximum deflection is 67 and minimum is 191. Okay, okay, no, it's soil pressure. Okay, sorry. Okay, so deform shape, go to show deform shape, and here you will select the load combination, dead load plus live load, and apply. So you can see minus maximum deflection is minus 14 and minimum is minus 40. Okay, so suppose you are getting deflection positive, that means you are getting uplift in the foundation, and that is not desirable for the foundation design. Okay, so whenever you're designing the foundation, please make sure you're not getting any deflection in positive direction. Okay, so here you can see the maximum deflection is in the maximum and minimum direction is in the negative direction. Okay, That means it's downward, not upward. So basically, the uplift. Suppose there is a groundwater table in your in your soil. There is a water table in your soil. Okay, and so basically, the water table will give you the uplift deflection. Okay, and if suppose there is a water table present in your soil, and it will give you the pressure, the water pressure that will act upward, and it will give you the uplift. So please make sure you have to check all the geotechnical report. Okay, so the water table, if the water table is mentioned in the geotechnical report, we have to take a different foundation. So for that we have to take the pile foundation. Okay, so what the pile will will give the amendment proper amendment depth into the into the soil. So we will have a appropriate amendment, and we will have appropriate as like appropriate strength, and our soil will take the pressure, take the load of our house, or you can see it's a G+3 residential building, you can say. Okay, and so now we will check for the design reinforcement. Okay, so here I want to give you one brief about how you can check one-way shear or two-way shear check. Two-way shear, okay, one-way shear or two-way shear. You have to check it for one-way shear and two-way shear. Okay, so I'm drawing a diagram right now. Please give me a time. So this is our isolated foundation. At the D distance, you have to check the one-way shear. Okay, and at the D by 2, you have to check the two-way shear. Okay, that is two-way shear is none other than punching. Okay, so you have to check this manually also. Okay, so it's none other than punching is there. Okay, two-way is punching. So we will check it one-way shear or two-way shear. Okay, so like if you want to see the stresses in the okay, so what we will do, we will simply go to show slab stresses. Okay, so we will see the slab stresses. Here you can see at the top, or stresses at the top face or stresses at the bottom face. Okay, so we will check the all the stresses and dead load plus live load only. Okay, so for that uh, okay, so here you can see okay, it's a shear, we have to check the shear. Okay, so it's V13 and V23 we will check. What is this? Okay, so what is this? Okay, so okay, at top face and it's S13 apply. Okay, okay, yeah. Okay, fine. I think this result we want. Okay, so you have to check everything at the stresses at the top face or stresses at the bottom face at S13 direction or S23 direction. Okay, three direction is vertical, or one is horizontal and two is vertical. Okay, so you can see you have to check all the stresses at top or bottom. I think it's same. It's not that won't be much difference. Okay. So let's check it the top faces. Okay. So how to check the, so what will be the permissible limit for the stress? Okay. It will be as per the IS 456. So let's go to the IS 456. Okay. Let's open the code. Not here. Let's open the code here. Okay. So let's open IS 456. Okay, so you can see it's a permissible shear stress. Okay, when shear reinforcement is not provided, the calculated shear stress at the critical section shall not exceed Kc tau c. Okay, so we are not providing any shear reinforcement. Okay, so that's why we have to take care of this check. It should not exceed Kc tau c. Okay, so this is the permissible limit we like I was talking about. Okay, so we have to calculate this permissible limit. So here you can see it's a two-way shear check. You have to check it for the two-way shear. Okay, and you can see it's a critical section. It's the effect of opening on the critical section for shear. Okay, it's the effect of opening. Okay, fine. There is no opening in our criteria. There is no opening. Okay, so I think this is the formula. So tau c is equals to 0.25 under root FCK in the limit state method. So we are using limit state method. So this is the formula 0.25 under root FCK. So FCK is 25. FCK is 25. We are taking. So it should be under root 25 will be 5 and 0.25 multiplied by 5 and is equals to 1.25. Okay, tau c will be 1.25. And ks we have to calculate. You can see here ks into tau c. So we know tau c, we have to calculate the ks. Okay, and ks, you can see ks is 0.5 plus beta c, but not greater than 1. And beta c is being the ratio of short size to the long side of the column. Okay, so it's a short side of the column divided by long side of the column. Okay, so here suppose we have to check it for this one. Okay, let's check it for this one. Okay, here you can see the stresses. Like, okay, you have to check the stresses here. You are seeing the stresses here. Okay, I think it's perfect. Here I think you are not seeing any much stresses. So let's check it for these two foundation. Okay, so let's open our drawing here. So there these are the two foundation. Okay, so here I think these two foundation, right, at grade 3 you can see at grade 3 and at grade D or E. Okay, so grade 3 and grade D or E. So these the size of these column is C1 and C1 is 300 by 450. Okay, so let's come to our code again. So it's short divided by long, so it will be 300 by 450. Okay, so that will be 0.6666. So let's take it 0.67. So if you will multiply with the 0.67, you will get the permissible limit. So permissible limit is 0.8375 at d distance. Okay. So for one-way shear, it should be at a d distance. This is the permissible limit. And for two-way shear at the d by 2 distance, this is the permissible limit. For both of them, this is the permissible limit. Okay. So let's check it. So here you can see this is the column face. Okay. And okay, so 1 minute. Let's go to here again. So this is the column face. Okay. So if you want to check it, like suppose draw dimension line, okay, from face at d distance. Okay, what is the depth of this footing is 500. Okay, so it should be zero point 0.5. Okay, so you can see it's zero point 0.5 here. Okay, at this location and at d by 2. So at 2.25 here. Okay, at these two locations, you have to check it. So let's open the dimension line and you can untick in the checkbox for show width. Okay, so now you can see the dimension. Okay, so here you can see it's 0.25 here and zero point 0.5 at this location from face of the column. Okay, so we will check the stresses at this location and at this location. So let's put the cursor here. And okay, so how we will do it? Okay, so let's put the window here. I think it will. Okay, 1 minute. Let's put the window here. Okay, this dimension draw dimension window here, and click apply. Okay, so here you can see we are getting 1 minute. Here we are getting 0.79. Okay, so you have to check it like this. Okay, here you have to check it like this. So from we will start from this location, and here you can see. Okay, 1 minute at this location. You can see it's 0.91. Okay, so our permissible limit is 0.83. So here you can see it's 0.91. Okay, it is 0.91. So what you can do, you can increase the depth. Okay, you can increase the depth, or what you can do like this. Okay, so this is how you can check the stresses. Suppose it is an for so you have to check it for this direction also. Okay, you can see here you are getting 0.91 again. So what we can do, we can increase the depth. Okay, we can increase the depth. Here also you can see it's 0.91. And yeah, that's so for the d distance. Let's do it again. Okay, for the d distance, put the draw dimension window line here and click apply. So here you can see it's under permissible limit. Okay, it's already under permissible limit. Okay, it's 0.27. So it's passing in two-way shear check. Okay, it's not passing in one-way shear, but it's passing in two-way shear check. So what you can do, just increase the like there is no much difference from zero point 0.9 and 0.83. So what you can do, you can increase the footing size by 50 mm. Okay, it will be perfect. So, so what you can do, your D is increased. Okay, your D is increased. So suppose your 0.25 is here. Suppose 500. Okay, so let's assume your foundation depth is 600 mm. Okay, so now your I think your d by 2 will be 0.3. So your 0.3 will lie at this location. So you can see 0.3. We are getting 0.3 stress at this location. So it's already passing the check. Okay. So for zero point 0.6 it's already passing the check. So what you can do, you can increase the just because you can increase the foundation depth just by like 50 mm or 100 mm. Okay, that's how you can design it. Your foundation, you can check it for one way or two way shear check manually. Okay, and yeah, that's how you can do the design, right? So or you don't need to check for one way also. Okay, if your footing is passing for two way check, it's good. Don't check it for one way. If you are too concerned about your foundation design, you can check it for one way also, but I will recommend you to don't check it for one way shear check. Okay. So I think it's perfect. Now we will check it for the reinforcement design. So we will check for the design reinforcement. So design reinforcement, you can see all the widths we have. So for the design reinforcement, you have to go to the slow show slab design. So in this show slab design, you have to choose a strip base, not final element. Okay, choose a strip base. It will give you the perfect or accurate results. It should be enveloping flexural reinforcement. Okay, we are not providing shear reinforcement, so we are only seeing the enveloping flexural reinforcement. Okay, and here you have to take for show bottom rebar. Okay, in isolated foundation we won't provide top rebar. Okay, suppose it's only G+3, it's very small building, so in G+3 we won't provide top rebar. Okay, and there will be, I think, we won't get much top reinforcement also. Like I will show you right away. Don't worry. So here you have to take a reinforcing specified in rebar object. Okay. Show value at controlling station on diagram. You have to take that one also. We are seeing the reinforcement for the layer one only. Okay, so here you can take typical uniform reinforcement specific below. Okay, we will take this one, and we will take defined by bar area and bar spacing. We will take this one. Okay, and I think we will open one uh, photo. Okay, this photo we will take it. But there's one. Sorry. Okay. NSCon, GST, structural SAP model. Okay, I think view. We have to go to the view and large icon. Okay, okay, okay. I think 1 minute. That model. Okay, so I have I will open it in. I think I have sent one of my. I think I have sent you. I think Arnav, I have sent you the file, right? Hello. Okay, Arnav is not there. Okay, fine. Arnav is not there. Okay, so let's check it for Arnav only. Okay, okay. Media. There is no much media, right? Files. Okay, 1 minute. Let me open structural design. from COI, GST, 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 instruction unit, contact tools, OneDrive. Mm, yeah, this one. Okay. So this is the all. So what I have done, I have calculated for every spacing. You can see for 12 dia, the reinforcement is 1.13 area. Okay. For 16 dia, it's 2.01. For 20, it's 3.14 centimeter square. Okay. So these all are the areas in the centimeter square. It's 25. It's 4.9. It's 32. It's 8.042. Okay. So it's all these all are areas in the centimeter square. So I will, I will teach you how you can download it. So how you can calculate the all the area required. Okay. So if you are providing like 150 center to center spacing, how much area you need for the 12 bar or 16 or 20 or 25 or 32. Okay. So there is only, I think, 1 minute. Uh, okay. Let's close this. Okay. And let's go to here and new and okay. So here we will. So suppose you want to calculate the total area by using what number of bar or spacing. Okay. So what are the spacing you are using? What are the dia you are using, or what are the total? What is the total area you are requiring in the foundation? I'm giving you the brief about the calculation. Okay. So here you can see it's a total area. So it's pi by 4 into d square. It's the area of a steel bar. Okay. It's a one steel bar into 1000 divided by spacing. So this is a simple formula we are using to calculate the area. Okay. So let's calculate for 12 bar. Okay. So here let's open the image again. You can see it's 12 mm. So we will calculate for 150. Okay. So here you can see it's pi by 4, 3.14 divided by 4, pi by 4 into d square. Okay. So that will be 12 into 12. So it is 113.04 in, it is in square. Okay, so here it's 1.13, it's in centimeter square. Okay, so what we will do, we will divide it by 100. So now it's in centimeter square. So now I want to calculate for 150 center to center spacing total area. Okay, so it will the calculation will be around about 1 minute. Okay, so you can see you have to multiply it with by 1000. Okay, so let's multiply it with by 1000. And spacing is 150. Okay, so let's divide it by 150. So 150, it's in Okay, no, 1 minute. Let's divide it by 150. Okay, so we have to take the spacing is in, it should be in Okay, suppose total area is in centimeter square and it's also in centimeter square. Okay, so it will cancel out. Okay, so it should, you have to take it is in Okay, it should be in Okay, so here you can see you are getting the total area. It is in 7.536. It's in centimeter square. And here you can see we have right 7.53. And that's how you can calculate for every spacing. Okay. For every spacing, you can calculate the area. So I will give you the brief about what is the use of this calculation. Okay. So here you have to go to the show slab design. Okay. For layer A we will, so for layer A we will see, so we will see it. Okay, So only tick here show bottom rebar. Okay, please select the typical uniform reinforcing specific below. Okay, let's click apply and close. So let's check the unit first. Okay, so unit, so for the area it's in kilonewton mm and c. So what we will do, we will simply select kilonewton centimeter and c. Okay, for area, for the rebar area also we will select kilonewton centimeter c, and for the rebar area it should be centimeter square per meter. Okay, we are calculating the area in centimeter square. That's why we have to take this one and click OK. And then you have to go to the slab, show slab design. Okay, so let's take it this one, defined by bar area and bar spacing. Okay, and here you can see the bar area you are getting in centimeter square, and spacing is in mm. Okay, so let's take it 0 and 0 here, not take it 0. Okay, let's take it 0 0.1. Okay, 0 0.1, 0 0.1 here also, and 0 0.1 here also. Okay, and you have to apply it. Okay, so we are show reinforcement. Okay, why it's there? Okay, 1 minute. Let's take it 150, 150. Okay, let's take it 1.13 and 1.13. Apply. Okay, okay, fine. So for the layer A, okay, so what we are doing here, we are providing 1.13, or we are taking spacing is 150. Okay, and at the bottom we are taking it. So you can see we are only take the bottom one. Okay, in layer A. So in bottom, what we are doing, we are providing 12 bar at bottom. It's 1.13 or 150 Okay, you can take it 100 also. Okay, you can take it 100 also. So what we are doing here, so we will apply it. So you can see the 12 bar is not, it's applicable for these bars only, for these foundation only. Okay, so now we are not, so we are here additional reinforcement, we are not getting any additional reinforcement. You can see there is 0 0. Okay, so what I will do, I will reduce it. Let's take it, it's 0.2, and it's 0 let's take it 0.2 and apply. So here you can see it's, we are getting additional reinforcement here. So it's not require, it's not so you can see the required reinforcement is greater than the provided reinforcement. This is the provided reinforcement. So what you have to do, you have to take it 1.13, or let's take it 200 spacing and apply it. So it's also, you can provide 12 dia of 200 spacing at these two slabs. Okay, in these two foundation you can provide this reinforcement. Apart from these two, there is a lot of reinforcement we are getting. Okay, so you can check it one by one. So what I'm doing, I have prepared one table for that. Okay, so here you can see the table. It's a detailed table is here. Okay, so what you can do, you can simply select the, you can copy it, and you can name it as F1. So you can name it, it as a F1, and F1 here also again, these two. Okay, and you can write, 1000 by 1000. Okay, and depth is minimum, you have to take it 200. Okay, so minimum depth is 200 here. Okay, and you can see the bottom reinforcement along and along length and along width, it should be 12 200. Okay, it should be, you can say, so 12 dia and 200 spacing. Okay, and I think you can delete this, or you can copy this from at this location to this location. Okay, and control that. Okay, 1 minute. You can copy this from here, from this point to this point. I think it's perfect, right? You can take it, you can move it also. Okay, and top reinforcement, we will check it for the top reinforcement also. Okay, for these two foundation, we'll check it for the top reinforcement. Okay, so this is along length, we are getting this one. Okay, along length we are get along length we are getting 12 200. You can see here. Okay, you can, okay, let's check it, let's take it 200. Okay, I don't know why it's 150. Okay, and now we will check it for the along width also. Okay, so for along width in vertical we will apply it. So you can see it's also applicable at the along width also. Okay, so we can take this reinforcement along width. So what we are doing for along length and along width, we are taking same reinforcement for these two. Okay, so now again we will check it for the layer A and apply. So here you can see what we will do. Let's take it 150 spacing. Okay, and you have to always 1 minute. So let's increase the dia. So it's 2.01. Okay, so let's increase the dia. So it should be 2.01 here, and okay, let's take it 200 here and apply. So now you can see we have to provide additional reinforcement again. So what you can do, you can decrease the spacing. You can apply. Now you can see for these foundation, we can apply 16 dia and 150 spacing. Okay, so you can see this one, this one, this one, this one, this one, and this one. So like we have to check the dimension also, these for these foundation. So suppose the dimension is different, you have to name it as a different foundation. Okay, so let's open the dimension lines. Okay, so you can see it's 1.715, 1.6, 1.6, 1.5, 1.5, 1.6, 1.6. Okay, it's 1.6, 1.6, 1.5, 1.5. Okay, 1.5. So for the same width, you can take same name. Okay, so for these two foundation, we can take same name. For these two foundation, we can take same name, and for these two foundation, we can take same name. And for I think this one, this one, this one, and this one, we can take same name. So let's take it F2. Okay, so I think for F2 here, we will take name F2. Okay, it should be F2 here. Okay, and we will copy the name. We will copy the name. This should be F2, and it should be also F2 here. Okay, and for the F2 we will provide, for the F2, what we will do, we will provide 16 150. Okay, 16 dia 150. So at the in the footing schedule, what you can do, you can change it, you can change the dimension, and it should be, it can be, it's, you can see it's in x direction it's 1 5, and y it's 1. So always write x direction first and y then y. Okay, So I think no, always take the maximum dimension. Okay, maximum we have to take always, not x and y. It's 1750. Okay, and 1.15. Okay, and what we are providing the depth. You have to see the depth again. Depth also it's 300. Okay, so go to here and you have to change the depth. Okay, and it should be 16 150, and it should be 16 150. Okay, so for now for these one, so what you can do, you can it's you can see it's 0.322 you are getting. So it's very less reinforcement 0.322. You can ignore this 0.322 up to 0.5. You can ignore it. Okay, if you are getting, suppose you are getting zero point 0.8, so you can't don't won't ignore it. Okay, up to 0.5 you can ignore it because it won't give you much difference in the design. Okay, because we are already taking 1.5 factor of safety. So you can see it's 1.6, 1.6, and it's also 1.6. So we can take same name for these four. Okay, so let's take it F3. So now I'm doing it very fast to save the time. Okay, our time is more important. Okay, it's F3. It should be 1.6. Let's check the what is the depth. I think depth is 300 and this depth is also 300. Okay, it's 350. So you can see depth is different. So we can't name it. We can't name these four foundation. We can't name it as the same. We can't name the same name. Okay, for these four, it's also 350. So we can take these two separate and these two separate. Okay, so let's take it F3 and it should be 300 here. Okay, and it should be F4 and it should be F3 F350 here. Okay, and it should be deleted and deleted. Okay, so let's take it to these two and you can copy it from this location here and here. Okay, so we have checked it for along length and let's check it for along width. Okay, so along width we will check it. So for layer B also apply. Okay, for layer B also applied. So you can see along length it's not it's not the provided reinforcement is less than required one. So what we can do, we have to increase it along width. So along width what we will do, we will take it 100 mm spacing and apply it. Okay, so what, okay, why it's more? Okay, so why everyone, okay, it's 13.39. Okay, it's quite high actually. You can see it's 11.45. No, okay, okay. For 16, it's 200 mm spacing. Okay, so I think don't do it. Let's take it 150. Okay, okay. So it's 16 dia, right? 16. Okay, fine. You can take it like 150. You can see here. So in this foundation, you can provide 16 150 in this also. Okay, in this also, and this also. Okay, not this one. Okay, so 100. Okay, so let's apply it. So for every foundation, you can provide 100. Okay, so let's do it. So along width, okay, along width, we can provide 6 for every foundation. So you can delete it, delete it, delete it, delete it. Okay, so I think here it should be. Okay, so now for x direction, we will check it one by one. Okay, okay, so you can see 150 is there. Okay, so you can see for these foundation one, 2, 3, 4, 5. Okay, one, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think for you can see here also we can provide 16, 150. Okay, and for these foundations we will provide 1600. Okay, so let's do it. So first we will name it. First you have to name everyone. Okay, I think you have I think you have a good idea about how to do the naming and how to assign the reinforcement. Okay, I think everyone have a clear idea about it. So now I will do it fast. Okay, in a very fast way I will do everything. Okay, so it's F1, 2, 3, 4, 5. Okay, so F1, 2, 3. 3 is there, 4. 4 is there, but it's 350. 5. Okay. So 5 is this one, 1.5, 1.5. Okay. So 5 is this one. Okay. And this one and this one, right? Okay. So these three is okay. These three is okay. This one is also okay. Okay. So it is 350. Can copy this. So F1 is there, F2 is there. Okay. 2 is there. Okay. 1 minute. F2, which is F? Okay. F3. F3 is this. 1 minute. This is F3. Okay. And this is F4. Okay. This is F4. This is F3. So, or you can, or what you can do, you can, there are like many method. So let's go to here and this one. Okay. So let's assign slab data. 1 minute. Assign. Okay. And properties. Okay. 1 minute. So what you can do, you can go to the slab properties. It's a support properties. Okay. There is slab one, slab rebar, Excluded show mass area property. Okay, area, please take the area property and okay. So you can see all the depth and all the dimensions is already written here. Okay, so what you can do, you can take a, you have to go to the file, capture picture current window xdxf. Okay, and you have to save the dxf and open the dxf. No, and I think take it full. You have to go to the quick access. Okay, so once you will go to the quick access, you will get the file at the, okay, above here. Here you will get the file. Okay, and you can open the file. Okay, it's currently in use. I think it's exporting it. Okay, do it again. Okay, press Z, enter, E, enter. Okay, you can see. Okay, so what you can do, you can delete it. You can delete this one. Okay. So here all the dimensions and the depth is written. Okay, here what, so what you can do, you can copy it and you can paste here. So what you can do, you can name it. You can name all the foundation here. Okay. So I think it's, let's copy this. Mm, mm. F3, F3, F4, F4. Okay, it's a 1.5, 350, 1.5, 350. So you can name it as a F5. Okay, so you can name it as F5. Okay, and it's F5. Okay, so I think this one is remaining. It's 1.9 so it's 1.9400. You can name both, both the foundation same. So let's take it, F5 हो गया, then F6. Okay, and ये हो गया, then it should be 2 point, it should be F7. Okay, let's take it F7. 2.1, 2.1 400, it's also F7. So these four will be F7. Okay, and this one will be F7. This one will be F7. Okay, and now I think these fours are remaining. So you can see it's 1.8, it's 350, 350. So it can be F8 or F9. This will be F9. Okay, F8 or F9. Copy and paste here. This is F8 and this is F8. This will be F9. Okay, and this will be F9. Copy this, paste here. Okay, I think we have assigned all the name. Okay, for this one it will be F10. You can copy this and you can paste. It will be F10 here. Mhm. So like I think we have assigned all the name. Okay, so what you can do, you can make a block for these one. Okay, please make a block and press B space. Okay, name a block for name. Okay, and click OK. And now whatever you will change in this drawing, it won't affect any drawing. Okay, because suppose the same layers names are there. So if you go to the select similar, it will select another layers also. So it won't affect anything in your drawing, in your current drawing. So always work in a blocks. Okay, so suppose I will select it and go to, I will select similar. Okay, and suppose I will copy the name and paste at this location. 1 minute. Okay, I think there won't be any issue for other drawing. Okay, so let's close the block. Okay, save. So you can see this the name of these here or here is similar. So suppose I will select this and 1 minute. Okay, this is block. So if you remove the block, you can press X space. Okay. Suppose I will click this name and go to the select similar. It will select this one also. Okay, so that's why we will work in blocks. Okay. So what I can do, I can copy this, not copy, move this, and I can uh, paste here and I can write all the name. Okay, I think F3 is 16 by 16. Okay, for F4 is 16 by 16, 350 for F5. For F5, you can see here for F5. I think F5 is it's 1515 350. So you can write 1515 and 350 here. Okay, for F6 is 1919 400. Okay, and for F7, you can see for F7 it's 2121 400. Okay, for F8 you can see it's 1818 350. Okay, and there is F9 F10 also. So what you can do, you can copy two data and you can paste. Okay, and you can extend the lines. You can extend these lines. Okay, and you can again extend these lines. So there is F8, then F9, and then F10. Okay, for F9 it is, you can see for F9 it is 2 by 2. Okay, it's 2.2 by 2. So it's 2.2. Okay, for F10 it is 2.5. And for F9 depth is 400, or it will be 500 for F10. 400 or 500 will be F10. Okay, so you can see here we have successfully done it. So let's remove this foundation. Okay, like this one. Okay, and let's go to our safe model. Okay, let's go to let's run this and see the reinforcement in X direction. I think in Y direction we are sorted. Apply. Okay, so you can see for these foundation, for these 1 2 3 4 5 6. Okay, so let's take it like this one. Let's take a new and select this. Okay, so like for this one we are providing 12 150. Okay, no, not 12, 16 150. Or for another one we are providing, for this one we are providing 1600. Okay, so you have to check the name, you have to check the name and what is the name of the footing and what are the foundation reinforcement, for what are the reinforcement the foundation we are providing. So let's go to here in the drawing. So for, I think, for F2, F3, F5. Okay, F5 and I think F6. Okay, F6. So F6 tak we are providing 16150. Okay, and now for F7, 8, 9, or 10. So for F7, F8, F9, or 10 we are providing. For middle one we are providing 1600. Okay, for middle one you can see. Here we are, what why we are putting 1600, because these two foundation name is same, or we will always take the maximum one. Okay, please take always the maximum reinforcement. So here, so suppose I will write 100 here. Okay, and apply it. You can see we don't have any extra reinforcement. Okay, so now here, I think provided reinforcement is greater than the required one. So I think we have checked everything in the foundation. Okay, so now we will go to the schedule in our foundation schedule. Okay, so here we will take it 1600. Okay, we will copy this and we will paste it here. Okay, so now our foundation schedule is prepared. Okay, so you can delete this one. Okay, so our foundation prepared for the bottom reinforcement, and for the top reinforcement, to check the top reinforcement, what we will do, we will select the top, show top rebar, and pick both of the layer, and we will just simply apply 1 point. We just apply 0.1 and click apply. Okay, so let's take it 0.5 and apply. Okay, so 1 minute. So at the top, okay, so at the top we will check it, right? So let's take it 200 mm spacing and zero point 0.2 here and apply. Okay, so we are getting top reinforcement. Okay, in some of the isolated foundation, you can see we are getting here top reinforcement. We are not getting top reinforcement in the middle one. Okay, so let's apply for the 8 mm bar. Okay, for the 8 mm bar. 1 minute. For the, no, not for, it's okay. Let's provide 12 bar. Okay, 1.13. 1.13, 1.13, and apply. Okay, so 200 mm में 1.13. Okay, uh, let's calculate for the 10 bar. Okay, 10 bar. 3.14 divided by 4 into 10 into 10. It is 0.785. 0.785 and apply. Okay, so it is also, there is no requirement for the, so let's take it 8 bar. Okay, 3.14 divided by 4 into 8 is 0.50. 0.5024. Apply. So okay, here are some extra reinforcement you are getting in the top. So what you can do, you can provide 10 bar. Okay, 0.78. Apply. So you can provide 10 bar at the top in every foundation. Okay, so let's take it 10, 200 in the both the way. Okay, along length and along width both. Okay, so you can delete this one, and what you can do, you can copy this, you can select this, you can copy these two, at here. Okay, and again what you can do, you can copy this, like you can copy like this, and you can copy and you can paste here. Okay, and that's how you can save your time. You can again copy this and paste like this. Okay, and you can copy this and you can paste like this. Okay, so now we have prepared our foundation schedule. If you can okay, so you can see there are the walls. Okay, there are wall, there is no beam. Okay, so you can see there is no beam. So for the interior wall, what you can do, you can provide the brick wall foundation. Okay, there, suppose there is no plinth beam, and above the plinth beam there is a above the plinth beam there is a wall, so you don't need to provide any foundation over there if there is no plinth beam over there. So for the interior wall, you can provide this foundation. Suppose at the exterior wall there is no plinth beam, so you can provide this 230 thick brick wall foundation. So you can see here for walls not over plinth beam. Okay, and for walls over plinth beam, no foundation need to be provided. Okay, so you can see this is a grade slab detail. Okay, this is the grade slab detail, and you have to provide the minimum rebar at the grade slab. Okay, it will be like 8 to 100 mm in the both ways. Okay, in the 8 bar dia, 200 mm spacing in both way. Okay, so it's a typical details. It's a typical detail for the isolated foundation. So you can see here, you can see there is only bottom reinforcement. So what you can do, you can select this. Okay, and you can select everything. Okay, 1 minute. You can select this. You can select like this. Okay, and you can select this and you can mirror it. Let's do mirror, and you can select these 2 points, 1 point and 2 point, and yes. No, 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 not erase. Erase the source object. Okay, okay, yes, you can take. Okay, so now you can see you have provided the top reinforcement also, or what you can do, you can like merge this one. Okay, and you can merge it like this. So you can provide bottom and top reinforcement. Okay, and I think it's quite easy. It's very easy. If you want this file, please write yes in the chat box, and I will give you the file.